A very good morning, all. Myself, Shaga Anoosha, Assistant Professor from Department of IT. Today, I would like to explain the topic here is Introduction to Machine Learning. Before going to the about machine learning, I would like to explain from where this machine learning comes from. So, this is a completely subset of artificial intelligence. So, what is this artificial intelligence? What purpose we are using this artificial intelligence is? First thing is this artificial intelligence is it is creating some applications then only to so that a machine can perform itself without the human intervention, so interference. So here for example, if we take self-driving cars, Amazon shopping cart, these things we can say because self-driving cars are without human interference, the car itself can drive. So that is how it creating the applications in this artificial intelligence. So after artificial intelligence we comes to this machine learning, so that we can say that this machine learning is a subset of artificial intelligence. So what we are doing in this machine learning is, so this in this machine learning it provides some tools to analyze or to categorize or to predict some data. So prediction purpose or to analyzing purpose, categorize purpose, we are using this machine learning. So for that purpose this machine learning is providing some tools. That is how this machine learning works. So this is what I would like to explain here, what is the machine learning. So this is to learn from we have to teach the machines to learn from the data, and without the human interference it should work itself. So I would like to explain these things with the two ways, like traditional programming and machine learning, how this works, this data and programs. Actually in traditional programming, in a way of like C language, data structure, C, Java, what we do to execute some program to get an output, first we have to give the data and then programs, then in the computer it itself process the data and everything, then finally we'll get the output. So in machine learning what happens is, first we have to give the data and we itself have to provide the output. Then in computer itself it has to process by applying some algorithms and tools and all, then finally we'll get the program which has a model, we can say that. So I would like to explain this magic. This is a magic in a way of gardening. I would like to explain in a way of seeds, nutrients, gardener, and plants. So, what is the main aim of this getting model? Very good model is when we have a more data, then we'll get the better model. We'll find the better model in the end. So that is how seeds we have when we want to plant. Grow some plants, first we need to give the seeds, then that is equal to algorithms. So that we should have some algorithms to get a better model. Then nutrients, how much good nutrients we will give to the particular seeds, then that much healthy plant will get. In the same way, how much data we have, then better model will get finally. So gardeners are like we here and plants are like programs. So that is how we are getting. I would like to explain how these algorithms and data and programs are works in a way of gardening. I'm explaining here. And finally here, where we use this machine learning is some sample applications I'm giving here, like web search and finance, e-commerce. In all sectors we can apply these machine learning things. And here we have different techniques we have in this machine learning, three types of techniques: supervised learning, unsupervised, and reinforcement learning. One by one I will explain here. First thing is supervised learning. What is supervised learning? These are the three different techniques we have in this machine learning. One by one, supervised learning is nothing but here we are taking the labeled data, so that we can train the machines using some particular data. So labeled data is nothing but here we are taking particular labeled data to train the machines in this machine learning purpose. So supervised learning technique, completely we are taking the labeled data here. See, in unsupervised learning what we are taking is completely unlabeled data. So from that unlabeled data only we are training the machines. Reinforcement learning is we are taking some agents, we are using some agents and an environment to produce some actions and rewards. In that way we are using this reinforcement learning technique. So here we are applying different algorithms in different techniques. So supervised learning, we have for different algorithms like linear regression and logistic regression, support vector machines, and k nearest neighbor and decision tree. When it comes to the unsupervised learning, we have k means and db scan, principal component hierarchical clustering. And when it comes to the reinforcement, q learning, sr, and monte claro, and a deep q network, because each algorithm works depends on the problem statement. So these are the different algorithms in different techniques we are applying in this machine learning problem statement. When it comes to the supervised learning, as we discussed till now, we are taking the completely labeled data to train the machines in the supervised learning, right? So here in this supervised learning, we are taking two different problem statements, which are like regression and classifications. Before going to that, I would like to explain with the example supervised learning how we are taking. See, this input raw data we are taking in a way of, see, completely it is a labeled data. So we are taking the labeled data to train the machines. So input raw data we have taken as a fruits, and supervisor means we are the supervisor working. We are taking training data set and desired outputs. From that, we are applying some algorithms like supervised learning. We have logistic regression, linear regression algorithms. We are applying those algorithms here, and we are processing it, and finally we are output. We are getting some output which are like, what is this, which are apple and peas and mangoes. So labeled data we are taking, and finally we are taking what is that, means name of that particular fruits. In the same way, if we want to categorize some like different cats or not cats from bunch of animals, different animals, so we can take this test data, and we are applying some machine learning algorithms like support vector machines, these things algorithms, and we are categorized from a bunch of animals. We are categorize it as a cats and not cats. That is how, means yes or no, like categorical data. So that is how this supervised learning works. So here we have two different problem statements there in this supervised machine learning. That is how classification and regressions. So how this classification and regression works means, see, classification is nothing but completely it is a categorical data we are taking here. See, when it comes to the like yes or no, true or false, spam or non-spam, in a coming to the email purpose. So that is how completely a categorical data in classification. For example, if we take a student, I want to predict particular student either be fail or pass in their exams. How can I predict? First of all, I should take a data set. So I need to take some data set. Which data set I have to take? Person, the student who spends a time on particular play or else on games or study. So when a student spends a time, more time on like for example, if we take 10 hours, in a 10 hours, 3 hours on study and 7 hours on play, so we can say that he will be fail. So like 10 hours, 7 hours on study and 3 hours on games, then we can say the person will be, we can predict the student can pass. So we can observe that the complete data set we have taken it is completely a categorical data, either pass or fail. So in that case, we are taking this classification problem statements. So when a problem statement in a way of categorical data, then we can apply this classification techniques. So that is how we are applying, means this classification is completely about categorical. So in the same way, like pass or fail, both we can pass or fail, like binary data, multi-binary data we can take here. See, this is a credit scoring, we can take that, differentiate between the low risk and high risk. One of the example here, this how can we say that here I'm applying some condition. If the, like we are taking to get the bank account, bank loan, when his income is greater than the zero, then savings are the greater than, then we can say that he will be in a low risk, other he will be in a high risk. That is how we can apply here. And next thing is these are the different exercises I would like to explain what is comes to the classification, like predicting the gender of a person by his or her handwriting style. Because gender of a person means it is completely categorical, either female or male. So a can, we can say that gender, female or transgender, right? So that is how we can apply here. Predicting house price based on area, like based on area, this house price means either the means we need to find out either which classification, which of the problem statement is here. So that is how we can apply here. Next, coming to the regression, it is a continuous process. Which kind of problem statement it will be is, it is a continuous process. It should not stop anywhere. So how can we say this is, for example, if we take I would like to predict some house rent. So which data set I have to take means, number of rooms and area of length of the house. So means square feet we can take. When the number of rooms are more and the area of the length of the house is more, then we can predict that house of the rent will be high. So when the number of rooms are 4, like in the same way, like if it is a number of rooms are 2 and square feet are 90 or 100, 120, then the cost estimation of the particular price of the house will be different. So when the number of rooms are 6 and square feet are 8, then the 800, like then the price of the house will be different. So it is a continuous process, there is no particular end here. So that is how we are taking here this regression problem statement. And here we can say that dollar or weight, we are taking here the relationship between regression problem output variables are real values, like dollars or weight. So dollar value will be definitely a particular continuously changing. Today some value will be different and tomorrow will be different, and day after tomorrow will be different. So it cannot a constant value, it is a completely a real value. So that is how we can weight of the person also same. Weight of the person or things, we can say that it is not a constant weight. Today or tomorrow there will be a change. So that is how we can say that the regression problem statement is a continuously processing statement. When the problem statement is a kind of continuous process, then we are taking this regression process. So dollar and weights, I have taken here examples, and some real world examples we can take that just now we discussed, predicting the price of the house, and predicting the impact of GRE scores. Depends on GRE score, college admissions will be different. Today MSET rank 1000, if we get, there will be a different colleges will get, and next year if it is 1000 or 2000, then will be a different admissions. So that definitely it will be a changing, it's not a constant. And predicting the sales based on input, and predicting the weather prediction also, it is completely changing, it's not a constant, cloudy or monsoon or everything, right? So and regression exercises, we can take that predicting age of a person, and predicting nationality of a person, and whether stock price of a company, and given input or cat or dog. So which of these comes under the particular regression problem statement, and it all combining combination of both problem statements, like regression and classification. So in this, which one is a regression problem statement, you have to find it. That is how the exercise I have taken here. Age of the person, and age of the person is completely, it is nationality of a person, and stock price, it is completely, and given input is cat or dog. So finally if we take that cat or dog, it is a categorical, right? So here we can say that it is a classification problem statement. Stock price also, it is continuously changing, we can say that it will be a real value, there is no constant, right? We can say that it is a regression problem statement. And nationality of a person, age of a person, you have to find it. That is a reason I given is some exercises. And next thing is unsupervised learning. It is a completely classification purpose. We can say that here, for example, there is no particular concept of predicting value. We have to find out the group of clusters. We have to find out the clusters. So what kind of clusters means, simply I would like to explain with one example. I would like see, for example, a person wants to open particular products. So means launch his products in a market. So what kind of for that purpose he would like to send some coupons with with particular mails. So to whom I can send that mails, gift coupons means, example I'm taking here as, I'm taking one of the example data set. Which kind of data set I have to take is the customer's income and who spends more on that. When a person when a person's salary is high but expenditures are low, and there are four kind of categories, we can say that person's income is high, expenditures are low, and income is low, expenditures are high, and low expenditures and low salary, high expenditures, high salaries. So four categories we have here, clusters, and from that I would like to find who are having high income and high expenditures. For that person only I would like to send these particular gift coupons to launch my new product. So that kind of persons only put an interest on the particular products, right? So in that way I'm applying this unsupervised learning. So this is completely finding a clusters. That is how I just applied this unsupervised learning. This is how here it is completely we are taking the unlabeled data to train the machines here, right? So we have a lot of documents, or else we have lot of customers in that. From that I would like to particularly find a particular things. I would like to train that particular data. So in that way I just want to apply this unsupervised learning. In the same way here we are taking unlabeled data, and algorithms I'm applying, and finally I'm getting this output. And in the same way there is no labels. It is completely unlabeled data, and I'm labeling everything, like birds are one label, and animals and all. See, this is how unclustered data. From that I'm taking the clustered data. I'm just dividing that unclustered data to clustered data. So that is how this is what unsupervised learning. Semi supervised learning and reinforcement learning are a different combination of both things. Means this is completely both the combination of supervised and unsupervised. And the main aim of this reinforcement learning is to get some rewards. To get some rewards, awards we have to give, right? So when we take an example, like a student wants to study a very good, and then he will get that particular grades. So then officials, lectures will give the awards and rewards and everything. So that is how we are taking this reinforcement learning. So this is how criteria we have taken: definitions and type of data, and supervised, unsupervised, and reinforcement learning, machine learnings. What type of data we are taking, type of problems, and supervision, algorithms, what kind of, just now we discussed everything here. I just I put it everything in a way of tabular format. That is how we explain here. It is completely about introduction to machine learning, what kind of algorithms we use, what different problem statements we are taking, and what kind of data set we have to take for different problem statements, and with examples and with algorithms. I just explained with introduction of machine learning. That's how. Thank you.